Homogeneous nuclear reactor. Nuclear reactors generate energy through the fission of uranium nuclei of mass number 235. A uranium nucleus absorbs a free thermal energy neutron. That results in two smaller nuclides, 2 to 3 free neutrons, plus an excess energy for utility. The fission process begins with a start number of free neutrons ns inside the reactor core. A neutron may be consumed in U-235 fission. A fission event is marked as a red plus sign on the display. It results in a net increase of free neutrons Np in the reactor. Otherwise, a neutron may be absorbed by a non-fissionable nuclide in the reactor core. The events are marked as a blue minus sign in the display. It results in a reduction of free neutrons inside the reactor. Or that a neutron may escape outside the reactor, diminishing also the number of free neutrons in the reactor core. A graphite jacket is used to reflect some of the escaping neutrons. In the control panel, μF is the fission attenuation coefficient. It represents the absorption of neutrons per unit travel distance that results in U-235 fission. In a fission event, 2 to 3 free neutrons are released in capturing one neutron. The μA is the absorption attenuation coefficient. It represents the absorption of neutrons per unit travel distance by other nuclides in the reactor, without causing nuclear fission. At the reactor setting in the control panel, the non-fission absorption of neutrons is substantially low. The simulation accordingly yields the number of available free neutrons Np increasing with time. The situation is termed as supercritical. It leads to reactor explosion. At the alternative reactor setting in the control panel, the non-fission absorption of neutrons is substantially high. The simulation accordingly yields the number of available free neutrons Np diminishing with time. The condition is termed as subcritical. It leads to reactor stop. The number of free neutrons in the reactor has to be maintained at a fixed level. That requires a delicate balance between the reactor's parameters. Normally, the reactor is made slightly supercritical. Movable boron carbide control rods absorb excess neutrons under operation. Display 2 presents the simulation balance sheet of the nuclear reaction outcomes in the reactor under operation. Visit the website www.cyberphysics.academy for a full view of the tutorial. Send comments to contact@cyberphysics.academy.